Good day, learners. Welcome to a new video. It's a new day, new video. Okay, today we'll be doing algebraic expressions, but before we go into our learning, I'd like to remind you to please subscribe, comment, like, share. Yeah, the works. Make sure it reaches as many people as possible, right? Remember, we are not selfish here. We share with other learners so that all of us can benefit. Okay? Okay. So let's get into it. We'll be doing algebraic expressions. So remember, whenever you're looking at expressions, you know here you're going to simplify. You're going to simplify, and then remember expressions have no equal sign. Okay? So a specific topic that we're going to be doing today, we're going to be expanding. Oh yeah, we also expand. Okay, so we are going to be expanding and simplifying, meaning that we will be multiplying binomials by trinomials, by monomials, whatever. So before we proceed into doing all those things, I would like to start by defining the terms monomial. We know a monomial as an expression consisting of only one term, okay? And then we have a binomial. A binomial consists of, bi means two. So a binomial consists of two terms. And then we have a trinomial, which consists of, tri means three, okay? So a trinomial consists of three terms. And then we have another one that is called a polynomial. What is a polynomial? These two are polynomials, meaning that a polynomial consists of two or more terms. It can be 3 terms, it can be 5 terms, it can be 6 terms, it can be 10 terms. That's a polynomial as long as it consists of more than 2 terms. So this expression consists of more than 2 terms. So we can't say a monomial is a polynomial. It's not. Okay. Now let's continue to the next part. So the topic I want us to look at today is, okay, let me do like this. It's not use. The topic I'd like us to look at today is expanding and simplifying. We expand and simplify. So normally when we expand, you multiply the terms that are given there, okay? Okay. Okay, so the first one that I'd like to look at is, let's look at example 1. Here we are going to multiply, or they say we expand and simplify. The first example is this one. Okay, so we start by expanding this one. So how do you know what to do? Here they just said expand, right? So in order for us to expand here, and simplify. In order for us to expand here, you must look at what is going on here. It doesn't mean you must always multiply depending on the given expression. So when you look at this expression, you can see that there's a number there. And in between this number and this bracket, there is nothing. So you know that no sign, there's no sign, there's no plus, there's no minus, there's nothing. So no sign means multiplication. Okay, so I'm going to repeat. No sign means multiplication. So this means that this number 3 must be multiplied into everything that is inside the bracket. It must be distributed. We are going to use a method called distributive method. So meaning that we are going to distribute our common factor. Whatever is outside and it's multiplying the bracket, that is your common factor. Okay, so we are going to multiply this common factor. We are going to distribute it to everybody. So everybody must get a share, okay? And then now let's go. We say 3 multiplied by 3x squared. Then you're going to have 3x squared. And then you go, okay, 3 is positive, right? So positive multiplied by positive is positive. Okay, now let me write something very important here on the side now. I like to give my learners, I like to tell my learners to write a box. So this box normally means that is very important information. Okay, so whenever you multiply, plus multiplied by plus is equal to, so positive times positive is positive, right? Negative times negative is positive. And then positive times negative is negative. All right. So what do you notice here? It means that this sign is the same, okay? The sign is the same. These signs are not the same. So whenever you multiply signs that are the same, you get a positive. That is why when you multiply negative and negative, you still get a positive because you're multiplying these signs that are the same, okay? And then here now, when you now start multiplying signs that are not the same, that is when you get a negative, okay? Okay, so let's continue. Coming back to this one, that is why you have a positive 3 there. That is why when you multiply the positive sign by the positive sign, you get a positive. And then you multiply 3 by 3x cubed, which is going to give us 9x cubed, because 3 times 3 is, oh, sorry, it's going to be 27. 3 times 3 is 27. Okay. 27x cubed, and then positive multiplied by negative. These ends are no longer the same, right? So you're going to get a negative. Then 3 times 2, which is 6. Is there anything else you can do? You now check for your like terms. Remember, like terms, for like terms, you look at the variables or the alphabets that are there. They have to be exactly the same. So for them to be like terms, it means everything must be x squared and x squared, or x to the power 3, x to the power 3, for these two to be like terms. So now this is x squared and this is x cubed. They are not like terms. So it means there's nothing else you can do. You are done. You have expanded and simplified. Okay, now let's look at the second one. So here, if you can notice, or you multiply a monomial, you multiplied a monomial by a trinomial. Remember, a monomial is 1 term, a trinomial is 3 terms, okay? So I want you guys to remember that terms are separated by a plus and a minus. The reason why we say these are 3 terms is because they are separated by a plus and a minus. So when you look at this whole thing, you see, okay, x squared plus 3x cubed. You say, okay, that's 1 and 2. And then there's another one, there's a minus there, and then there's a 2. So now you have the third term, okay? Let me write it here. Terms are separated by a plus and a minus. This is also important information, okay? And then I want us to look at the multiplication of binomial by binomial. So let's go to example B. You're multiplying, let's say you're multiplying x plus 3 multiplied by x minus 2, okay? So here you're multiplying a binomial. Why are we saying it's a binomial by a binomial? Because here in this bracket you have two terms, right? I remember I just explained now that terms are separated by a plus and a minus, meaning that x and 3 are separated by a plus. So this makes it two terms, right? Same thing applies here. This one is separated by a negative, meaning it makes x term number 1 and 2 term number 2, okay? So now the multiplication of binomial by binomial has two methods. Né? So the first method is called FOIL. I don't normally advise my learners to use this method because sometimes they forget to multiply the last term. It normally occurs when you have to multiply the last term. So I always advise my learners to use the distributive method, but I'll show you how it works on this example, okay? So, but first I want us to start by using FOIL, right? So FOIL simply means first, outers, inners, last. So you multiply outers first. There are your outers, right? And then first, you multiply your first. This is the first term of this one. This is the first term of this one, right? And then you come with the O. O means outers. When you look at these two brackets, this one is an outer, this one is an outer, right? And then your I means inners. Terms that are inside are these two. You can multiply this one. And then your L means last, meaning this is the last term for this bracket. This is the last term for this bracket. That's how it goes. So let's go. First, start with our F. First, you multiply the first terms for both, which is x times x, which is x to the power 2. Why are we having x to the power 2? Because you're multiplying x by itself 2 times, which now introduces an exponent, okay? And then we come with our O, the outers. This is outside. This is outside. I hope you understand this now. So x times negative 2, which is negative 2x. Remember, the x is positive, the 2 is negative. So when you multiply signs that are not the same, you get a negative, okay? Sorry, and then we come with our inners, 3 times x. Both these terms are positive. So positive times positive, they're multiplying signs that are the same, which gives us a positive. So 3 times x, which is 3x. And then we come to the last part, L, which is the last. And then you multiply positive 3 times negative 2. Now you're multiplying signs that are not the same, which gives us a negative 6. And then remember, you must expand and simplify. So the part for simplification comes when you now look at your like terms. Are there any like terms? Yes, there are like terms. Here is our like term. Here is our like term. Remember, like terms have to have variables that are exactly the same. This is x to the power 1. This is x to the power 1. So these are definitely like terms. So you have 3 minus 2. So now whenever you add or subtract your like terms, you deal with the coefficients, which are these ones. Negative 2 plus 3. So 3 minus 2 is 1. So you're going to have plus x and then minus 6. Remember, in grade 8, we teach you that the coefficient, if the coefficient is 1, then it becomes invisible. So you have simplified, you are Done. And then let's come to method number 2, or if you use distributive law. If you use distributive law, you say, okay, now I have 2 brackets. I need to choose one that I'm going to distribute and one that I'm going to keep. Okay, so you can distribute any of the 2. There's no specific law whether you must choose the first one, whether you must choose the second one. No, you can distribute any of the 2. Okay, so I'm choosing to distribute this one. So what happens when you distribute? You take the first term of that bracket that you're distributing. You say, okay, and then which bracket are you keeping? I'm keeping this one, x minus 2. Okay, so from the first bracket that I'm distributing, I still have to distribute who? This term. You say, okay, plus 3 times my bracket that I'm keeping, which is x minus 2. I always prefer this method because in this case, you never forget to multiply anything. Okay, now let's go. And then now you multiply. You see here the monomial, multiplying a binomial. Monomial, binomial. See, that is so nice. Okay, x times x. You're multiplying x by itself how many times? 2 times. Introduce an exponent of 2. Okay, and then x minus 2. 2 different signs. We have a negative and then 2x. Next, continue. 3 multiplied by x. These signs are the same, right? So you're going to have a plus 3x, and then multiply the last one. 3 times negative 2. And multiplying different signs, meaning you're going to have a negative 4 times 2 is 6. Okay? Remember to add your like terms. Like terms, okay? So you have x squared plus x minus 6. And you're done. Okay. Okay, let's look at the last example, right? So for the last example, we are going to multiply. So here we multiplied a monomial by a trinomial. Here we multiplied a binomial by a binomial. So now I'd like us to look at this, a longer one. Right? So now we are multiplying a binomial by a trinomial. Okay. So we have a plus 2 multiplied by 2a squared minus 3a plus 5. Okay, so now this one, noma kanjani, you have no choice but to use the distributive method. That is the other reason why I encourage my learners to use distributive method, because by now you know what to do. Okay, and with the distributive method, you can multiply and expand any expressions that you want. Okay, so again, when it comes to distributive method, there's no specific bracket to distribute, and there's no specific brackets to keep. Okay, so you can choose any bracket that you want to distribute as long as you don't forget a term to distribute. Okay, so here I'm choosing to distribute a plus 2. You can also distribute this one, the trinomial, as long as you don't forget to distribute your 5. Okay, so I'm distributing this one and I'm keeping this one. Let's go. A multiplied by, oh, another thing is that you are not always going to see x, ne? Any alphabet is a variable. So therefore, it means that any variable can be used. Okay, let's go. So we are keeping this bracket. Okay, okay, are we done? No, we are not done. We still have to distribute our last 2. Let's go. 2a squared minus 3a plus 5. Let's go. Make sure everyone gets a piece of this a, okay? Because this a must multiply everything that is there. Let's go. A multiplied by 2. Another method I use for multiplication is to use the use the coefficients. So the coefficient of A is 1. So you say, okay, 1 multiplied by 2, which is 2, and then A multiplied by A squared, which is A to the power 3. Remember the log of exponent? When you multiply the same basis, you add the exponents. Okay, let's go. Term number 2, positive times negative, different signs becomes a negative. Now remember the coefficient of A is 1. 1 times this 3 is 3, and then A times A is A squared. 1 times 5 is plus 5. And then there's only one A, there's no A here, right? So it's going to be 5A, okay? And then continue to the next one, positive times positive, same signs means you have positive, right? So 2 times 2, which is 4, and then this A squared is not multiplying any A, so it remains A squared, okay? And then positive multiplied by negative, different signs means you have a negative. So 2 multiplied by 3 is 6, and then there's only one A. There's no A here to multiply, right? So you bring down your A. Now we multiply the last one. Positive times positive, same signs, a plus, remember? And then 2 multiplied by 5. 2 multiplied by 5 is 10. Okay? So now we have expanded. Are we done? No, we are not done. We still have to simplify, right? Now, whenever you simplify, that is the part where you must look for your like terms. Okay, like terms have to have variables that are exactly the same. Let's go. Do we have A cubed here? Do we have A cubed? No, meaning this term does not have a like term. We bring it down. 2A to the power 3, okay? And then let's go, do we have any other A squared? Yes, there is another A squared, meaning this term has a like term, which is this one. Remember, now it means you have to add or subtract, right? So remember I said to you, for you to be able to deal with these, you must deal with the coefficients. Remember, a coefficient is a number or a variable multiplying whatever you're looking at. In this case, our coefficient is 4 because it's multiplying our like term A squared. Okay? So you're going to say 4 minus 3, which is 4 minus 3 is 1, right? And then you bring down your A squared. You're going to have plus A squared. Okay? Do we have another like term? Yes, you have another like term. You have A, and here's another A, right? You say, okay, here's my other like term. 5 minus 6, which is going to be a negative 1. Remember, 1 has to be invisible. So it's going to be negative. So you say 5, and then minus 6. So whenever you subtract a bigger number from a smaller number, now you have a negative number, right? So you take the sign of a bigger number, okay? So you're going to have a negative 1, and then you bring down your A. So remember, 1 has to be invisible. So you have a negative A. And then does 10 have a like term? Nope. You're going to bring it down. So no more like terms here means you are done. Okay. Okay, so this is the end of our lesson. I hope you enjoyed. If there's anyone, if you'd like me to send you these notes, then you can comment down below. You can comment that you need the notes, and then how can we do it? Comment. I'll see. Maybe I'll share my numbers or whatever. I don't know. I'll see how I can do it, and then so that you'll be able to get the notes. Okay. Please don't forget to subscribe, comment, like, and share. Yeah. I hope this was informative. Okay. Come back. I'm still going to make more and more videos. Okay. Please come back, and yeah. Thank you for stopping by. Bye.